Okay, so this is the video solutions for the sections 4.1 to 4.4 study guide. If you want to graph a function, if it's not given in vertex form but in standard form, use the negative b over 2a trick to find the x coordinate of that vertex. And so you'll see I'll do negative 16 over 2 times 4. So the x coordinate of the vertex is going to be negative 2. Substitute that into x to find out what your y coordinate or your k coordinate is, the y coordinate of the vertex, and I can do that on my calculator to get the y coordinate. You can do it by hand too, but I just trust the calculator more. So negative 2 comma negative 9 is where the vertex of that parabola is. And so I can look, and you want to be careful, make sure that when you put the negative 2, you put it in parentheses. It's bad if you don't put those parentheses. You could get a completely wrong coordinate for the vertex. So just plot where that is, and I'll show you a little trick. To plot another easy point, that A, if you use that kind of like a slope, it gets you a distance of 1 point and 1 point only. So I could sketch a pretty good parabola this way by going up 4 and right 1, or up 4 and left 1. And just to show you that that does work, it's a pretty good sketch for that. Now you can also go into your table function in your calculator, or just plug in your own table values that you want. And I can just plug in some x values, generate the y values. But I guarantee that if I plot these points, like I'll match all the points that I have so far. The vertex being at negative 2 comma negative 9. Those points 0 comma negative 1 comma negative 5, negative 3 comma negative 5. And then you can find the y-intercept really easily. Notice how it's 4x squared plus 16x plus 7. If you substitute 0 into an equation in standard form, it's really easy to find the y-intercept. But just get a rough sketch, and that's all you're looking for. Get at least 3 points really accurate, and you can sketch the rest pretty well once you have your parabola. So this one's in vertex form, number 2. And when it's in vertex form, it's a lot less work to find the vertex. You just pull it right from there. Remember that the vertex equation is x minus h, so the x coordinate of the vertex is actually negative 8, not positive 8. And the y coordinate of the vertex is the minus 3. I plot that, and again, I can use that little a trick. Use the a, which in this case is 1, as kind of like a slope. I can sketch that. If you prefer to use a table, if you're not really familiar with exactly how that works, you can just plug in some x values. I always recommend with centering it at the x coordinate of the vertex. And I always choose some coordinates a little bit left of the vertex and some coordinates a little bit right of the vertex. And since parabolas are symmetrical, if you do your math right on one side of the numbers, it'll automatically show you that your math is right for the other sides. You can confirm it in your calculator, but this is me doing exactly what I did in my calculator. I'm just doing it by hand just to show you that you don't need to use a calculator if you're not comfortable using a calculator. You can plot your x and y values right there, plot those points on the graph, and it just helps you get your sketch a little bit better. Again, you want at least to have the vertex perfectly, and at least to have like between 2 and 4 more points, pretty accurate to get a good sketch. And any more than like plotting like 5 points, and you're usually going to be off of the grid that's provided that I give you on a test. I'm usually going to give you a 10 by 10 grid, or 20 by 20 if you think of it that way. Again, we're given another parabola. It's in vertex form, which is easier. So we can have the vertex right away, plot that. We can use that little a trick, which the a is a negative 1, go down 1 and over 1. Or, again, use a table. I suggest centering the table around your vertex, and you can just plug in those x coordinates and then figure out your y coordinates and plot those values right there. Number 4, it's in standard form, just like number 1 was. So I'm going to use the h equals negative b over 2a, h again being the x coordinate of the vertex. So here, my x coordinate of my vertex is a fraction. And again, to find the y coordinate, I just plug it into the original function. That gives me my k. And so there's my vertex right here. I know that it's downward facing, so I know it's going to go down. And again, the a is negative 3. So I'm going to go down 3 and over 1 to each side. And that gives me a pretty rough sketch of the graph right there. So that's how to graph parabolas. Here we're going to be having a graph in standard form. I'm still using those skills that I used to graph it. So I want to identify the axis of symmetry, the max or the min, And so the negative b over 2a formula, when you're given an equation in standard form, gives you the x coordinate of your vertex. The reason why that's important here is because the vertex is always either your max or your min. In this case, because it's a downward facing parabola, because that negative c right here, it's going to be the max. So the max is 14, and it occurs when x is 3. The domain of a parabola is always all real numbers, and then the range is from negative infinity to 14 because, again, your max is 14 and it goes down from there. So that's why it's negative infinity to 14. Here we have an equation in standard form, so we don't have to use the negative b over 2a formula. We're just given it in standard form. And then this one's an upward facing parabola because the a is positive. So this time the vertex y coordinate is going to be a minimum instead of a maximum. It's concave up. So the axis of symmetry is x equals 6. I forgot to do the axis of symmetry on the last one, but the range and domain's always all real numbers. This time the range is 7 to infinity because 7 is the lowest number going up. Another equation in vertex form. So that vertex, again, is going to give you your axis of symmetry, and it's going to give you either your max or a min. Well, how do I tell if it's a max or it's a min? Well, look at the a. The a is negative, which means less than 0, which means this function is concave down. So that is going to be a max because it's at the top of the hill there. The domain is always all real numbers. And your range, since 1 is your maximum, your range is negative infinity to 1. For this one here, we're not given it in vertex form. Instead, we're given the equation in standard form. So that's where you want to use negative b over 2a to find your vertex. The reason the vertex is so important, once again, is because it tells you where your axis of symmetry is. It also tells you where either your max or your min is. So if you plug in that h value or that x vertex value into your equation, it gives you the y value, which is negative 4. But how do I know if that's a max or a min? Well, a in this case is 4. That's concave up, so that means it's a minimum at negative 4. Your domain is still all real numbers. And then your range is, since negative 4 is your lowest value, that should be a negative 4 right there. It goes from negative 4 to infinity, not positive 4 to infinity. So I apologize for that. This equation, it's in standard form. I'm going to take it from standard form to vertex form, again, using negative b over 2a. Can't overstate how important that is, the b in this case being negative 6, the a being the negative 3. I can find the x coordinate of the vertex. Then to find the y coordinate of the vertex, which I call the k, I just evaluate the function at the x coordinate of the vertex. So the vertex is negative 1, comma negative 5. The axis is x equals negative 1. And we want to write that in vertex form. So we have the h by doing the negative b over 2a. We have the k by evaluating the function at h. Now, how do we figure out the a? We could substitute some values and points in there, but we don't need to. The a in standard form is negative 3, so the a in vertex form is still negative 3. So there's your equation in vertex form. We're going to start factoring expressions. Here, we can't like FOIL it. All we can do is factor out of 2. When you factor out of 2, you just get 2 times 8 minus m squared. This cannot be factored any further because 8 is not a perfect square. For 11, we can factor a negative x out of both terms. For number 12, that one you can do the FOIL factoring. There's a plus on the end, so the signs are the same. So 2 negatives factors of 12, that up to 13. For number 13, we have, I'm going to keep trying factors of 24 until I get some that sum up to negative 5. A lot of 6 and 4 don't work, 12 and 2 don't work, 24 and 1 don't work, but 8 and 3 will work. But here's the problem. If I do k plus 8 and k minus 3, I get a plus 5k. I want a minus 5k. So I just switch the signs because the numbers were right, the signs were wrong, and that's how to factor that one. 14 you should recognize as a difference of perfect squares. So your favorite way to get a 9 is 3 times 3. Favorite way to get a 4 is 2 times 2. And then you just alternate the signs. Notice that I can check why there's no y term because it kind of cancels out right there. Number 15 is written backwards. It's not in descending order. Not that you can't factor it this way, but it's just better to write it in descending order first. I'd rather that negative 10 be in the middle. And this is not a difference of perfect squares, but this is a perfect square binomial. Since it's the same term twice, I write the term and then squared. Number 16, I just guess and check these. 2 is a prime number. I'm going to choose different Ways to factor 6. 6 and 1 don't work well at all. I'm going to purposely put another factor of 6. I'm going to put the 2 on the left, the 3 on the right, because I know it's wrong, just to show you that when you have an A value that's not 1, you sometimes have to swap the numbers to get the right answer. Now I can put that 1x and that 1 in front of x, or I can choose not to put it. It's really up to you. If I want to find a quadratic model given 3 points, I can try to do it by hand. It is possible, but I'd rather do it on a calculator. If you do it on a calculator, all you have to do is enter those 3 points, put the x coordinates into L1, the y coordinates into L2, go over to stat, calc, hit enter a few times. Now this right here is going to give you your formula, but you have to write that. You have to translate that in standard form. So make sure you put the A, the B, and the C, put those numbers in place of those. If I try to do this by hand, I'm not saying it's impossible, but it's more work than it's worth, especially since I don't know if any of these are my vertex. I'm going to have to write a bunch of complicated systems to solve this, but number 18 maybe is worth the effort in doing this by hand. Here's why this is easier. Because 2 of the y coordinates are shared, I know that since parabolas are symmetric, that the vertex of that parabola is going to be right in between. Now, I know that the x coordinate of the vertex had to be 1, and since they happen to provide me with a point that's x coordinate is 1, therefore I know that thing's a vertex. But we have to give the final answer in standard form, so we still have to do a little more work than you might want to. But using the little trick about A's and how it kind of connects with slope, I can see that the A value is going to be 5. And if you want to turn that from vertex form into standard form, you can expand that x minus 1 squared. You have to distribute the 5. You have to simplify. Still, it's a bit more work to do by hand. What if we just use quadratic regression on the calculator? So I'm going to use option 2 here. If I go into my calculator, I hit stat, I go to edit. I'm going to put the x coordinates are the same as the previous one. All I got to change is my y coordinates. And I go to stat, calc, option 5, quadratic regression, and I just hit enter a few times. And notice how I get the exact same equation. 5x squared minus 10x plus 0. I don't need to write the plus 0 because when you add 0, here I want to go from a graph to an equation. Now I can still use the trick where I just pick a few points. I can use quadratic regression, but I'm just going to try to do it by a method without my calculator. So I'm going to write this thing in vertex form, which is how we want to write it anyway. The vertex is 1, negative 2. It's right there on the graph. You can see it. I can plug those points in. The only difficult part is finding the A, but if you notice that if I go over by 1 from the vertex, it goes up by 2, then you can see why the A is 2. Let's say you aren't comfortable using it that way. If you want to find just your A, you can plug 3 points that hit like nice corners on this graph, and I can notice that my A is still going to be 2 here. I can do it from the beginning using my calculator, but the calculator puts it in standard form. It takes a little bit of work to get it into vertex form. It's not impossible. But having it, writing 2 times the quantity x minus 1 squared minus 2, being able to do that right away without using a calculator is probably easier than trying to put it into vertex form. But I will show you how to put it into vertex form from standard form on question 25. Here, again, we have the vertex. It's negative 2, 4, because the vertex is left 2 and up 4. I just shoved those into standard form. The only difficulty is finding the A. The A, if I go over by 1, the height of the vertex only changes by 1. So also because it goes down, that means that this is actually going to be a negative in front of there. So that should be a negative 1 right there, not a positive 1 right there. So I left off my negative here. But if I do quadratic regression, I will see that my A is equal to negative 1. So don't forget to put the negative there because it is downward facing. Number 21. I want to factor this. I prefer to factor out the GCF first. It makes things a lot easier. Divide essentially everything by 3, and I'm also pulling out 2 x's as well. Once I do that, I get a trinomial that can be factored further into x minus 6 and x plus 2, and since neither of those can be broken down further, I know I've factored this all the way. If I look at 22, we want to write the equation of a parabola with a vertex at 3, 2. And we want to talk about what the vertex, what the axis of symmetry is, and I want to just give 2 other points in that graph. Now, the other 2 points depend on what I choose my A to be. That is optional. Your A could be anything. I'm just going to choose an arbitrary number for this A. I'm going to choose for this thing to be upward facing. So let's say it's going to be positive, and let's just make it a positive 3. If the A is 3, that means that for the first change in X, I'm going to go up 3 and over 1. And so I get to the points 4, 5 and 2, 5. Those have the same Y coordinate. And that's just one example of an answer you can have there. Number 23, we're factoring a perfect square trinomial. 25 and 9 are both perfect squares. So that's my go-to is to put 5 and 3 there. The signs are both negative, and you should write your final answer as the quantity 5x minus 3 squared. 24, I want to write the equation of two parabolas that have a common vertex and are reflections across the x-axis. I'm going to try this. I'm going to write just two parabolas that have their reflections across the x-axis. But if I don't put their vertex on the x-axis, they won't have a common vertex. So I have to have those two equations share their vertex on the x-axis for them to have a common vertex. So I'm going to notice that my k has to be 0. I can't shift either of these up or down from the x vertex, and I can pick any value of a I want. That number 2 there could be anything. The number 5 could have changed. I just chose the 2 and the 5 arbitrarily, but all that matters is that your k has to be 0, and those 2 and -2, they just have to be opposite sign. Here I'm going to write an equation in standard form, and instead of showing how to convert it to vertex form, I'm going to refer back. I can make a parabola right here. If you look at number 9, we did exactly that in part 1. The most important part in getting from standard form to vertex form is using that -b over 2a to get the x coordinate of the vertex. And remembering that the a in standard form is the exact same a that you see in vertex form. Once you have that, it's really easy to do. And again, to get the k, you just substitute that value of h into the equation. For doing it the other way around, if you look at number 18, when I expanded this vertex form equation and distributed the 5 and simplified, that's how to get something from vertex form back into standard form. So you can just re-look at number 18 to see how to do that one. For 26, also, we can look again at what we did for our standard form. Notice that the x coordinate of your vertex is the average of your x-intercepts. So let's say we have an x-intercept at 6. Let's say we have x-intercept at 0. That guarantees that the vertex x-coordinate will be at 3. Now, that tells us automatically what the x-coordinate is. We don't really care what the y-coordinate is. I could have put this parabola upside down, and it still would have came out to an x-coordinate of 3, and maybe it would have a positive y value for the vertex. But the vertex of the x is always the average of your x-intercept there. They're both a distance of 3 away. So that's it for this study guide. Good luck.